এটা কত তাড়াতাড়ি করছে স্ক্যান করলাম আমরা মনে হচ্ছে 10 বাজার সাথে সাথে স্ক্যান সিসানে দেয় 2 নাম্বার
लेकिन बहुत लहजा होना चाहिए था मैं तेल स्पिनर ना लहजा था वेस्ट इंडीज अगर मेरा वास लगता था
अभी कौन से मैच शुरू होंगे
क्योंकि मैं एक बैट्समैन ऊपर से गायब कर देता मैं स्पिनर राज में ले जाता क्योंकि वेस्ट इंडीज की जो विकेट्स है ना वहां पे स्पिनर बचता है फास्ट बॉलर बचने नहीं।
अभी कौन सा T20 मैच शुरू होगा
हाँ ना
T20 का मतलब क्या
है
बीस
20 कहते हैं ठीक है मतलब 20 आगे फिर 20 मतलब 20 ओवर
Đi rồi tuổi thì nó đi mình cái
ये ओवर तोलम अभी ये ओवर सिलम होना
পেপারে টিম হয়ে যায় পাই না তো সবাই পায়নি
बोतल दो मैं पानी लाया
এইটা ঠিক হই রকি বুঝছো যখন নাম লেখছে না হ্যাগো দেয়নি নাম লিখে দিছে তাহলে হয়তো বা এখানে মারুফের কোনো ইয়ে আছে দেখাই পাই বিচারে পাই না
मारुफ नहीं देख के ये भाई तुमने स्किल भाई
अरे नहीं गेम पर पड़ा खूब खुश हो गए बच्चा
Okay. Okay, I think guys who are joining online, I think they also can hear me, right?
Yes.
Okay, then let's start. Today we're going to start the spring training of IMSA software training. The first session is on like Python. We are especially targeting for the meteorology, not for the other specific areas, meteorology and the applied sciences. So here I am planning to go with like the overview of Python and then the installation of Python. Maybe you might have Python installed like different ways. Then we will go with the Jupyter Lab because we are going to use the Jupyter Lab as our scripting interface. So the next thing is like practical Python syntax. We will learn some basics and still am preparing presentation. So I think that what else will be continued in the upcoming sessions. So the first one is like the overview of Python. So if we discuss about Python, can someone say what is Python? According to your opinion, what is Python? I'm not talking about that big snake. According to your opinions, what is Python? So typically everyone know like Python is also like programming language. But a language, Python is a programming language. It's like philosophy of readability and simplicity, because when you know about the other languages, like if you know like R, MATLAB, or if you are familiar with other coding languages like Java and those stuff, you know that Python is much easy to read and is simple. If you run like several lines of codes in other programming language, you can do the same thing with fewer lines in Python, and it's easy. And it's also object-oriented language, object-oriented high-level programming language. And it's like Ruby, Perl, PHP, MATLAB, and R. If you work with MATLAB and R, you are much familiar with Python. It's not like C, C++, and Java or Fortran. It's like different because those are not like object-oriented high-level programming languages. So the next thing is like what make Python attractive is the high-level built-in data structures. It can combine data structure combine with dynamic typing and dynamic binding. These features make it ideal for rapid application development. and make a scripting glue language seamlessly connecting the existing components together. Like you can connect two different softwares using Python also. The next one is like the simplicity of the Python. It's more simple, and you can find a lot of tutorials and lot of learning materials online, especially regarding to the Python. If you are familiar with the software programming languages, you will see now the future is more oriented into the Python. Everyone is shifting into the Python, even the programming students, and because of the machine learning, even Python is capable of doing machine learning. So if you are going into the machine learning, you need to know about Python also. So next thing is why we need to use Python. As you know, like there are other softwares like MATLAB and the things, but if you use MATLAB, we are using actually the cracked version of the MATLAB. It's not free, and some even you cannot like go for the newest features in MATLAB without pay. But if you go with like Python, it's open source and completely free. If they release the latest update, you can download and install and try those new features. And even you can modify. And then it comes to the simplicity. It's the key benefit of the Python syntax. Like it's designed straightforward for the simplicity. And then the expressiveness. By expressiveness, I mean like you can write only fewer lines of code to do the same function that you are using. If you are using any other language to code, you can achieve the same thing in the Python with fewer lines of code. And it's powerful because it can handle very big data, and it can handle directly the data from the servers without even downloading. And the next thing is like it comes with like several libraries included. If you need something to do, you can search in the internet and download a library and put it inside your Python package and try to use that package. So if I click here, I have already added the default Python libraries. If I go here, you will see the default Python libraries that available in the internet that you can use. So here, if you go here, you can see the Python standard libraries, the standard libraries that comes with the Python installation. So these are the things that if you are familiar with Python, you know at the top of the code, we are using like import library name as, then we type some name. So we are importing these libraries. So you can go here and check each and every libraries like comes with Python by default. But in our specific cases, we have to install the libraries for our specific needs. These are typically comes with Python, but we are not using these things much more often. So if we go to the next slide, it's on like where is Python used? So what's your opinion about you guys? Like where we are using Python? We are using Python in programming. We are using Python in meteorology. We are using Python in AI and accounting and those kind of things we are using. It's because Python is like ubiquitous. It tends to go to a scripting language. Even if it's a programming language, we can use it as a scripting language. Then the Python ecosystem has grown due to the readability and the openness, because it's an open source software. Everyone is using it. So we have the lot of crowd with the Python, and everyone is focusing on this one. So we have it's still evolving as a language. So if if it is not running in a shell script, it will be the next language that we will use in the future. So the next one is like scientific Python. With me? Yeah. Fever light. Yeah. Yeah. Because when you are like running Python, you can directly open your like debugger window and you can see what is the error, exactly where is your error. But in other languages, you cannot do that. And it's like bugs free because Python, when they release a newer version of Python, they like do the testing and then release. Because if you go to the Python website, you can see there's two release version like stable, Python is stable and Python, there's another one, they didn't mention like unstable or something. You are typically downloading the Python stable version.
You don't need to write too much code. Yes, why you two line
No, I think he is asking about this thing, the fever bar, this one. It's like if you download the Python stable version, it comes with like fever bugs because they check what can go wrong when you are typing the script. They check for the issues that are coming. So then the scientific Python stack. So this is what we are using, like Python. If we are using Pythons, we have to use modules. I will discuss about the modules more briefly in the upcoming session. But if you just fire up the Python by like installing the Python using, go to the Python website and you download it and install in the PC, you can run it. But there are no core modules that are needed for the scientific analysis and those kind of things. So you have to install those things. Then you can have a Python like for the scientific programming, because here you can see Python is not a scientific programming language. It's not a scientific programming language. It's actually a programming language. But for our specific purpose, we are using Python. Like with these modules, we are using Python specifically for our D. You will see the stack. I have a graph in the next slide. You can see. And the scientific Python in terms of ecosystem of packages enabling scientific science in the Python. So due to this thing, like due to the modularity, we can develop our own packages. Because I will discuss about these packages in the upcoming sessions. You can see those packages are developed by like guys like you, like the scientists, and they are available freely on GitHub and like open repositories that you can download them and use it. So this is the scientific Python stack. So here you can see the Python is in the bottom. So here if you go to if you go here, you can see the Python is the base. So this is the basic language. So we can divide this into different sections. So we are using especially this one. We are going along this one because MetPy is the thing that we are using, like it's domain specified. So domain specified, this one we use for meteorological applications. And these are the core libraries that if you need to go like analyzing and these kind of stuff, you have to use like NumPy, Matplotlib. This one is the favorite library for like displaying. And if you are handling NetCDF for multi-dimension data, then you have to use Xarray. And you are familiar with these things, I guess. If you need like scientific analysis, like regression, correlation or something, then you have to use SciPy, this library. So then we have to go for like the specialized things. Here we use like sometimes we are using Dask or sometimes we use directly Python, or then we are over the top of that thing we are using MetPy. That means MetPy, if you get MetPy alone, it comes with these packages included. Sometimes to work the MetPy, you need to have these packages. Otherwise, even though you download this library, it's not going to work. Because you need to have all the underlying packages in your Python environment.
Everyone is independent library.
Yeah.
So if you have, for example, MetPy, you put the other library into this.
Yeah. Yeah. Sometimes it comes with some packages are coming with like a bundle. So all the necessary files are comes with along with the package. If it is not coming with as a package, like a library, then you have to download all the necessary files for that thing. And then you have to check the version. Sometimes you might be like confused with the versions. To work some functions in the MetPy, if you are especially focusing in the MetPy, to work those things, you have to check the version of your MetPy and what kind of what version of NumPy or Matplotlib is familiar, like working 100% perfectly with your current version of MetPy. Sometimes you might have the latest version of NumPy, but you have the older version of MetPy. Then there's a confusion between them. Then when you try to do a plot or something, then errors might occur. So you have to be careful when using Python packages. So here I'm going to discuss about like packages and the modules. Modules are like the things that come alone, and packages are like comes with the bundle. So all the necessary things comes if all the necessary files and the libraries are there, then we can name it as a package. But if it only comes as a one library, then it's just a module. So these are the building block of Python that make it more powerful. So here you can see Python ecosystem has like over 200,000 Python packages. Even it's like updating like daily. So day by day is keep increasing. So here, the next slide we will discuss about the choosing right packages. This is the most important thing. If you are doing like, I think some guys may interested in meteorological applications. Some guys are interested in like oceanography or something. So then you have to choose the right packages for your need. So that's the first thing. So here I just mentioned like 3 rules when choosing some packages. The first one is like you have to check to choose like well-established packages. I will list some packages in the upcoming slides, so you can go there and check. And the established packages mean you have to look that package have been around for a while. If that package is around for a while and a lot of guys are using that thing for the scientific analyzing or those things, then you can go directly with that package without any issue. Then the next one is like large community support. Because these things, since we are using these things like it's open source, no one is getting paid for like building these repository like packages and libraries. So it's like free. So you have to check for the community support also. If there's a community base, you can go there and ask. If you like, just imagine you faced a problem while using a MetPy library. In the MetPy, you can see, go to the website of the MetPy and you will see there's a section for support. So you can go to that support section and then you can post your issue. When you're using this library, I get this kind of error. So you can post it with a screenshot and then the community will support you. Because there are other guys who are using the MetPy library. If they also face the same problem as you, they might can help you. But if you choose a package with a small community support, then you are stuck because you have to find the solution by your own. Then you have to check whether it's like efficiently code efficiently. Like when you're using some libraries, you can see they like highlight what are the parameters. If you are using especially one function, what are the arguments you need to pass into that specific library that you are using. So those things are also like well written inside the code. So you have to use check whether those things are there. So we will discuss this thing during the practical session. So the next one is the Python package indexes. So here I like categorize some Python packages into different areas. So here we have like for the first thing I categorize it for the general utility. So this one will be used. These packages will be used by everyone who are doing meteorology, the oceanography, or applied any other applied sciences. So something they can use these general utilities. So they will definitely use these general utilities. Then when you accessing the data, Like if your data is OpenEDP enabled, then you can directly access that data without downloading it into your PC. So there are some libraries for that. So you can check on the data access library. Then comes to the visualization. So this one is, I think, this is the most important thing for the all of guys, because when you do like paper publication or something, you have to visualize whatever the results you got. So these are some libraries. Here I mentioned some libraries about visualizing. Then it comes to the meteorology. In this slide, you will see some packages that are directly for the meteorological purposes. And also for the oceanography, here you will find some libraries. And then if you are interested in climate analysis, here you can go to this one and check for the packages in there. And then we have the data reduction. You are doing like temporal or spatial data reduction, because if your data is much higher, then you have to do the temporal or spatial reduction of your data to handle to reduce the size of your data. So the next thing is like spatial grids, and the final thing is like modeling. If you are into WRF modeling, and if you are interested in other kind of modelings, like you have different models, I have listed some packages for the models also. So the next one is, let's discuss about some packages like the general utilities. So the first one is the NCL. During the NCL lecture, I told you guys that NCL is also shifting into the Python. So here you can see, if you are familiar with the NCL, then you can directly go into this website. If I click here, I only link this one. So here you can see the GeoCat is from the NCAR also. If I go here about the gallery of examples, I can see how I can use this one. Just imagine you are need to do some analysis about regarding like climate data, like time series analysis. So here you can click this one, because these are some sample things. So here you have the code that you need to do a plot, a graph like this. Now, if you familiar with NCA, you will see some things, some of the code, Stephen, are familiar, like the same with NCA. So if you are doing some analysis like this, then you can go ahead and grab this code and use it. But the problem is, next problem is you need to understand what each of these line means. The next thing is that, so you have to understand. Even you can have some plots like this, moisture plug diagram like this. So here we read the NCL net CDF data, and we display all the parameters in there, and then we calculate using these functions, and then finally we plot the data. So that's from the NCAR. And even if you are into the oceanographic data, you can go to Python here. If you go here, you will see the repository of the Python. 60 loading. So here also you can see the NCL documentation. Also, if you need to read more about this thing, you can go here and you see support. This is the most important thing. So you have a support. If you encounter with an error, like using these libraries, you can go to the support section and submit the issue that you are facing. So this one is not loading. No why. So we will go ahead. Otherwise, it will take some time, because I will upload these slides into the WeChat group, so you can download it and check each of these packages. So this one is for the data access. So if you need to access CMIP6 data, you can use this package to access the data directly without downloading. So if I click here, it will take me into the package library, So here they mention everything, the quick start. If you click the quick start, they will mention how you need to install this one in your PC. And then you can go to the installation. They mention how you need to install this one. If you are using like Anaconda or a package manager like Conda or Anaconda, then you can use this one. If you are using Python directly, then you can type this in your Python command prompt and install it in your Python environment. But I recommend to go with a package manager like this. So otherwise, if you have multiple packages in your same environment, it will like collide with each other. Then if you go here, you can see searching in the database. If you need to search some data in the database, how you can do achieve it after installing. So this is the library that we are using, and then we have some inputs and outputs. We have to understand about these things. So after I upload this one, you can go into these sites and check. Sometimes you will find this one like these things are more useful according to your research area. So the next thing is like the ECMWF. This one is from the Center for Medium Range Weather Forecast, like from the Europe. So you can access their data also. And this one is the SciPy. You can download any data service which are hosted in the servers. So for this one also you can visit into that site and take a look at of how you can get data without downloading. So the most important part is of this one is like you can access the data without downloading into your PC. Sometimes accessing these data like download those data manually into your PC, and then you have to have some space in your PC also. But if you are accessing the data directly from the servers, you can save a lot of space in your PC. So those are the some libraries related to the data access. So the next thing is visualization. So when you are doing like plotting or something, these are the things that you can use. Cartopy, I think if you are familiar with Python, you have heard about this one. If you draw a spatial plot or something, this is the most interested one. The other one is Matplotlib. So if you go here, so let me click Cartopy and I will go into their website directly. So here you can see they also have a gallery. The simple thing is if you see something, you can directly go into the gallery and check. See, if you need to make a map, something like this, you can directly access that code. So even they have some plots for the vector data. So if I click vector data, then you can see the stream plot. If you need to make a stream plot like this, then the code is here. This is the code that you can use for this one. Then you can download it either Python format .py or as a Jupyter notebook. The both format is there. You can directly download this one. Now the next thing is like you need to understand this one. The codes are there, but the next important thing is you need to understand. So the next one is like CF plot. This is also a much useful package. So here you can see. If I go here, there are tons of graphs. If I need to do a cross-section analyze, pressure and height plot, I can click here. So here we have a plot with like pressure and latitudes. And the code that we have to use, we need to use to modify this one. Here you can see to create this plot, only these four lines are the things that we need to generate a plot like this. But if you're familiar with like NCL, during the NCL training, you know how many lines we need to type to get a plot like this. But here, we only need to type 4 lines to generate a plot like this. So you have to choose correct packages for your links. Because we have several packages. We can draw a map like this using any other package. But the problem is we have to write more lines. If you use that package, we have to write more lines. But if we use this one, we just need to write like 4 lines. Then we will get a graph. So you can see the different graphs over there. So even different projections. If you need to make a whole upload like this, it's also possible. But you need to understand this coding. To understand the coding, the best thing is go to these sites and check. Even they have some training material. So they have some training documents in the GitHub. So you can go there and check. It might comes with the data also. So the next one is meteorology. This is the most important thing that we are focusing on. So if we are doing some visualizing or something related to the meteorology, we can use these libraries. The famous one is this one, the MetPy. It's the most famous one. So if you need to visualize WRF output or something, you can use the MetPy. Here also they have like here also we have the community support. So whenever they release like training or something, you can see on this site also. And even events. So here, if you go to the events, they are organizing some workshops. So you can join into these workshops to get more information about these things. And they also have the documentation. If you go here, they have the documentation, the latest release. So here also we have the example gallery. The best thing is the example gallery. So if you need to have a plot, something like this, if you, the whatever the thing that you are looking is there, then you can click and get the code. Instead of writing the code, this is the best way. If you are learning something new, this is the best way. Like instead of typing something from ground to top, you can use the existing code and then you can modify it according to your need. So if you need to make a plot like this, like the station data, then you can use the above code, this one. Because these things are just comments and the descriptions. If you remove those things, you can see the code is not that low. To generate a plot like this code is just simple. Because these lines are comments, no? If something begins from the hash, it's a comment in Python. So we can see it's much more easy with the Python. So the next thing is like there are any other examples also like this. Let me send this one into the group so you can check it right now without waiting. I send it into the group so you can download that PDF and click on each link and you can check whether something you like is there or not. Okay, so the next thing is oceanography. Even for the oceanography, we have these libraries. So if you are into oceanography, you can go ahead and visit these links and check these libraries. So the next one is like climate. If you need to create some climate indices and those kind of things, you can use these packages according to your need. So you can click and go into their official website and check. So here you can see if you are into like SPI, SPEI, PET, PNP or something, these kind of indices like drought indices, you can use this library to generate those indices. Here also you have some example command line invocations and those things in here. So you can click those things and check. Because now you see Python is going like it's multidisciplinary. So I cannot teach all of these things within like 2 hours. So I will only teach the basics, because here you can see all of these things are, we can see all of these things, the code is there. But what I think you need to know is how to code this one, how to read these lines. If you know how to read these lines, then you will you can even modify. If you know this line is doing this part, you can copy this line and just modify it according to your need. Even sometimes you can use the same thing. Instead of flux convergence, you are going to display another data. So you can use the same data, then you need to know where I can change the data when I plot it, and change in the title where I can do those two things. So if you can read this one, you can simply modify this simple code to display that data. So that's what I am focusing on. So the next thing is like data reduction. So if you are having like downloading a data, if you are dealing with a bigger data, you need to do some like scaling. Then if you are downscaling your data, then you can save some space and your computation process will be much faster. So for that, you can use these libraries. So here also they mentioned how to install these packages using pip or using conda, how you can install these things. And even here we have examples. So example of the use cases of these codes. So if I click here, this is like EOF. So if you need to calculate the EOF for the El Nino, you can see. So this is the plot and this is the code to generate that same exact plot. So you can see that everything comes like this. So even if you go here, they also have like developer guide, and even I think, yeah, they have the user guide also in here. So you can read this user guide to familiarize yourself with the function that this package comes in. So the next thing is spatial grids. So if you are working with gridded data, then you will need to use one of these libraries when you are dealing with the gridded data. So this library, like the gridded, is from the NOVA. If you are using the NOVA data, you can use this library. So if I go here, you can see they also have the overview, the installation guide. Using pip or conda, you can choose whatever the thing that you like. Then the tutorial. Also, they have some tutorials. So then they have some guidelines on how to use this specific library. They also included some references, that mean where they use this one. What are the functions that you can use with each module? So if you import this module, you can use these functions. So if you need to know about this one, you can click here, and then they will say like, okay, to use this one, you need to pass these arguments in this format. So you cannot pass it in any other format. So if you need to pass to here, if you use this function, then you have to have two variables. But the next thing is this one should be in NumPy array containing x coordinates and NumPy array containing y coordinates. You cannot pass anything else into this function. You can pass like NumPy arrays without coordinates or like only the numbers, then you will get completely like wrong output. So then next thing is like you need to know about these functions when you're using each Python libraries. So for that thing also you have to go to the official site of the package that you are using and go for the reference. There they will mention everything that you need to know when you are using that module. So the next one is the modeling. If you are into the climate modeling, these are the libraries that you can use. Even for the WRF for Python, you can use this one. It's for like WRF. So if you need to display the WRF outputs, you can use this library. So here also they give you some plotting examples. So here you can see Matplotlib with Cartopy. So using those two libraries, how you can display your WRF model output. So here you can see that the WRF out, the model output is calling as an HCDF file, and then they are reading the variable name SLT, and then they are plotting it. So you can see we have a lot of codes. The next thing, the important thing in here is the understanding the code. Here we have to import these things. NetCDF. So if we are using NetCDF data, we need to have a package which we can use like to open that dataset. To read that dataset, we need to have something like this. Then if we are dealing with arrays, then we have to have NumPy or Xarray to handle with the data. Then if we are dealing like, if we are going to plot something, then the next thing is Matplotlib. We have to use this one or either Cartopy. So here in this example, we are using the both Cartopy and Matplotlib for display. Now we will discuss about this example in detail when we come to the practicals. So here I just want to show you guys that how Python can affect for the each and every discipline that we are dealing with. So the next thing is the essential Python packages. So here I will discuss about the most essential Python packages that we need to focus, and I will discuss about these packages because no matter what kind of like if you are doing oceanography or meteorology or anything, you have to use these things. If you are handling with the data, here you can see the overall structure. So interactive environment. So we need to have a interactive environment. That means we need to have an environment that we can code. Without code, we cannot get any output. So that thing we can use either PyCharm or Jupyter Hub or Spider. Any of these interfaces can be used. Like these are the interactive environments that you can use with Python. Then you need to have some data manipulation libraries. So here you can see NumPy, Panda. These two libraries are data manipulation libraries. So here we have Matplotlib. This one is for data visualization. So here NetCDF4 and H5P. This one is like to read the NetCDF files, and the H5PY means HDF5. If you are familiar with HDF5 data and you need to read the HDF5 data, then you have to have this library. If you are reading NetCDF, then you have to have this library. So then the Cartopy. This one is like the spatial. If you are dealing with the spatial map, then you have to use the Cartopy. Then there are some other packages like Xarray, Dask, Iris, MetPy, Seagir. If I have some time, I will discuss about these things also. If we got enough time. So here is the overview of like the Python package for the meteorology. So here, if I zoom in, you can see we are using like GeoPandas, Seaborn. The Panda is the core, like NumPy, Matplotlib, Cartopy, then the DAS. So these are the libraries that we are using inside the MetPy library. So you can see we have to use this each and every package. So let me introduce you about some packages like NumPy. This is the foundation of the scientific computation. So if you are dealing with, here you can see arithmetic operation, statistical operation like bitwise operation, copying and weaving arrays like stacking, matrix operation, linear algebra. If you are dealing like to analyze something like this with your data, first you need to read your data. For that thing, you need to have a proper reader. If you are using text file or CSV data or something, first thing is you need to read that data. Then you need to import those things in as array. So to import those things as an array for the analysis purposes, you have to use this library, NumPy library. So it's the most fundamental package for the scientific computation in Python. So it can work with the multi-dimension arrays. So you, if you, I think you all know about the multi-dimension arrays. That means it has more than 2 dimensions. So it can have like 4-dimension data or 3-dimension data. That mean latitude, longitude, and time. So it's 3-dimension like NetCDF files. So it also contains some advanced mathematical functions, and you can use like linear algebra, Fourier transforms, and random number generation. And this one is, I think, the familiar with the MATLAB users. Are there any guys who are using MATLAB for their works? If you familiarize with the MATLAB, you know about these things. Because even in the MATLAB, we use the same thing like handling the data. So the next one is, next we have the Pandas. This one is also the data structure. Like
This kind of computing scientific computing such as radiology, operations, and so forth.
Yeah.
If there are any way that I can utilize the methods and the solution of how it is computed, or you just apply the tool and see the result, you don't see
yeah, that's why I'm using like Jupyter Lab. If you use Jupyter Lab, you can see. If you're familiarized with the MATLAB interface in the workspace, you can see what are the variables that you are importing and those kind of things. But if you use like Python directly, then you have to type the entire script and you didn't see any output. What are the variables that you are using? Those things cannot be seen. You have to print, like if you need to view the variable, then you have to use the print command and print the entire data set and check. But if you use like Jupyter Lab, they have another area for the workspace. On that area, you will see what variables you used and what are the data inside those variables you can see in the Jupyter Lab. Otherwise, you cannot see. Till the end, you cannot see. You need to know what exactly you are doing. So the next one is like Pandas. This one is also here you can see it's also a data manipulation library. Pandas, Xarray, and the NumPy. Those all the things are data manipulation libraries. So sometimes you might use NumPy, sometimes you might use Pandas, or sometimes you use both. So here we have a concept like data frame. So when I doing the practical session, I will teach you guys more about this one. We are using data frames. It's like handling Excel table. When we are using Panda, it's just like handling Excel table. It's similar to that format. When you are accessing the rows and columns, it's similar with the Panda data frame. You can search on this one. It's similar to the R data frame. If you work with the R, then you know what I'm talking about. Even in the R, you have this kind of similar frame structure. So the next one is the visualization. When it comes to the visualization, no matter what field you are in, Matplotlib is the king for the visualization. So if you need to display a time series graph or box plot or something like this, you have everything covered in the Matplotlib. So if I go here, so here you can see in the Matplotlib, you have plot types. So you have every plot, the simple linear plot, scatter plots, bar charts, then the stem plots, the stack plots, even histograms, box plot. You can see each and every kind of graph is there, even the contour plots. If you need to plot barbs, you can use this one. If you need to display like vectors, you can use Quiver. Then even for the stream plots, you can use this one. So it includes all the necessary charts and the graph that you need to use. Even if you are handling like 3D graph, if you need to create a 3D graph, you can use Matplotlib. So you can have a look. Just don't need to understand this one. You can click here and go inside and check. To create a plot like this, only these lines that we use. So when you understand this one, you can see we generate some random seed and then we multiply it by, and then we assign those into 3 data sets, and then we use the plot. Here is the plot function. To create the plot function, this is the plot function. Till here we are doing like making the data. Until here what we do is like making the data. So the Matplotlib is the king when it comes to displaying any sort of graph, charts, and those things. You need to know about these things only. You don't need to worry about those codes and those charts. You just need to know, okay, what's the main purpose of Matplotlib? If I am using Matplotlib, what I can achieve? Matplotlib is simply there to do the visualization, not to do data analyzing or those kind of things. It's just for data analysis. So you need to understand those things. So the Pandas and NumPy is there to handling the data. Then we have NetCDF and H5PY. So these two things are like when we need to read the data, we need to use these libraries. The main purpose of these two libraries are reading the data, not like doing the analysis or those kind of things. Only purpose is reading the data. When you need to import NetCDF file, then you have to have NetCDF4. If you are dealing with HDF file, like satellite images from NASA, you have to use H5PY. So it can handle HDF5 data format. So the next thing is the Cartopy. So this is the other most important thing that you can use, like when it comes to the geospatial maps. So even you can do like land mask and ocean mask without worrying about long codes. They also have the inbuilt masking capabilities in there, and it's easy to transform between the projections. If you need to plot your map in different projections, you can use this one because they have a lot of inbuilt projection types. So that's all for the introduction. So now you can see how Python is like covering a vast area. So you can see all of these libraries and all of these functions are inside the Python. So we need to understand these basic things. So I will teach you guys about NumPy, Pandas, how to handle data with NumPy, and then Pandas, how to do some simple visualization using Matplot, and then how to use NetCDF and H5PY data, and how to use Cartopy for the spatial data visualization. So if I have some time, I will go ahead with this one also, because we have something called like bokeh, this one. If you need to make an interactive plot, you can use this one, this library. This library is there to make interactive plots. You know, when you are creating a simple plot using Matplotlib or something, you cannot interact. Like you cannot zoom into a specific area and check the data. But if you use this one, you have the capability of zooming into the plot that you have already prepared. You can zooming into an area and check the data. So it's bit advanced. Like this one is only for to check the data, not for like the publication purpose, because you can interact with the data using this library. So for the example, if I go to their website, here you also they have some examples like demos. You can see, you can click and check. If I go for the demos, let me see whether there's any interactive graph over there. So you can see here I can change. So these things are not there when you use Matplotlib. You cannot change these things interactively in your code view. But if you use this library, your map will be interactive. So if you send this one to someone and he or she run the entire script, they can directly change these things and check, like interact with this map. But if you go for the publication, this thing is not necessary. So even like if you are putting a scatter plot, you have the capability of like changing these things. You can change and visualize your data. So this capability is there if you use that library. So that's it for the introduction. So the next thing is like installing the Python. I think how many of you guys have installed the Python? So for this one, I'm going to use the package management tool, because having a package management tool is the advantage when it comes to like dealing with the data. So if you are using older versions of like NumPy packages and those things, and you got a script from your friend, just imagine you got a script from your friend, but he used that script 5 or 3 years ago. But now those libraries are updated, like Matplotlib library and the basemap library and the like NumPy, Pandas, those libraries are updated version. We have updated versions. But when you use the updated versions in the old code, like the previous versions, the issues might occur. So if you have a different environment, you can install different packages according to your need. It's like containers. You can have a separate environment for your analysis. Here you can also install like NumPy, the version that you need. For this library, you can install the NumPy latest version. So when you are making the script, you can either use this environment or this environment. So you can organize your data if you use a package manager like Anaconda or Miniconda. So I suggest you to install a package manager tool. So it will be much more easier when it comes to like dealing with the codes. Sometimes you get some errors in your script when you are running your script, but you might confuse what's the issue. Sometimes you need to uninstall your entire Python package and reinstall it again. But if you have different environments, then you can only delete that environment and create that another environment for your specific coding. So we have to use a package manager like this. So here I have some steps to use the Anaconda package. So I have the setup with me, but I don't know how to share it with you guys. So you can download this setup and come with that setup for the next session. We are going to close at 8:30. 8:30 or 9. So you guys need to visit this website and download the latest version of Anaconda. So here if you go, because Anaconda comes with several packages by default, it comes with several packages included. That's why you can see big size. If I click here and if I need to download, you can see this file is around 904.39 MB. But if I need to download Python, I can go to the Python website. So if I go to the Python, the official directory, so if I go to the Python official directory, from here also I can download the Python, but I don't recommend this one. So you can download this one by clicking here. The latest version of the Python 3.1. Here you can see the file size is around 2.5 MB, 25 MB, around 25 MB. Now you see the two difference of these files. So the Anaconda package is around like 900 MB and this one is around 25 MB. So this is the basic version of Python. But if you download the Anaconda, it comes with some several packages already included. So I have installed the Python, the Anaconda navigator. So if I open the navigator, we share this link to download the Python. So I think all of you guys are using Windows, not Linux or Mac. So because when it comes to the coding, the commands will be different. So you have to go into this website and download the setup file. If you didn't install it, you have to go there and download it. Okay. Oh, you guys can also mark the attendance at the same time. And the guys who are joining online, you can take the attendance. So while you guys are taking the attendance, I can show this one. The Anaconda Navigator. So if you install the Anaconda Navigator correctly, you can see a window like this. After you opening this, you can see something like this. I cannot open it.
The one is looking at Anaconda. They need to notify.
Yeah. So just I think for the next session, we can go ahead with the installation. Just download the Anaconda setup and come with the setup. Don't try to install it by yourself. We will install in the class. So just you guys need to download the setup. You need to have setup with your PC, on your PC. So just download the setup. Don't install it. If you have the Anaconda previously installed it in your PC, it's okay because we can create a new environment and go ahead with the training on that environment. I think you all mark the attendance. So I will go ahead with this one because I didn't discuss about this one. When you installing the Python, you can use the package management tool. So here I will discuss about the installation of the Conda package and then the installation of Python packages. So when it comes to installing the packages, you can either use command line or even you can use the Anaconda Navigator. We will discuss about this one on the next class. So you need to know about the advantage of a package manager. Advantage of the package manager is because it's a tool or software application that help you to manage software libraries. These libraries are like tools in the toolbox. So you can have your specific tools in a specific toolbox. Otherwise, if you jumble those tools in the same box, it will be hard for you to find the proper tool for the proper function. Just think like that. So the next one is like installing the Conda package manager. So I just show you guys how you can download it. Just download this one and come for the next session, I think, because we plan to finish the class at 8:30. So that's it for today. Just download this one. I just give you the link. Just download that setup and come with the setup. So we can go ahead and install. So the Anaconda Navigator is like this. This is the package manager. And I talk you guys about the environment. So here we have the different environments. It's like different labs. If you are doing different analysis, you can use different labs. So here, if I go to the environment, here I have two different environments. So this one is the base environment. So we will discuss about this one on the next class. So the base environment, you should never touch this environment. When you are dealing with some coding or anything, don't touch this library. Just keep it as the default format. So whenever you are using something, just create a separate library for that one. So here you can see if I switch into my PyAOS lessons library, my packages, the install packages on that thing will be changed. So we can, I think we can discuss this one in the next class.
No, I can write my name.
Finish some workshops. Will get the certificate.
Okay, guys, we are done for today. You guys on ada mana nih kalau paling tinggi ini dia ampun tuh.
PPT share.